nice to have you all here. My name is Linda Leischel. I'm the district manager for the San Juan Islands Conservation District, and we're one of the co-sponsors of this series. I'd like to thank our other co-sponsors, National Park Service, Madrona Institute, League of Women Voters, and several others. There's a whole list of them up here, and it's been really great working with all of them and pulling this series together. So I'd like to talk to you a little bit about one of the programs that we have. It's a community solar program. If you were here last week, you heard me talk about this. Some of you signed up to get more information about it. And I'm going to pass this around, so if you're interested, and if you haven't signed up yet, go ahead and fill out your information. If you did sign up, you'll be receiving information in the mail very soon if you haven't already. The community solar program is community solar for our schools. It's a program that's going to benefit our introduce Dr. Nick Bond. Nick is a principal research scientist at the Institute for the Study of Atmosphere and Ocean at the University of Washington. He's also our state climatologist, and he loves studying weather, specifically Northwest weather, Pacific Northwest weather. And he calls himself a science or a weather geek and a weather nerd. He particularly likes events, so he loves Alaska in the winter and Florida in the summer, storms and rain and all that kind of thing. So he'll be giving us lots of good information tonight about our weather and about climate in general. So with that, Nick.
Thank you. Thank you. On a day like today, this isn't as amusing a slide, I would say, because actually, please note that in the corner there, I'm referring to January 2054. How many of you remember David Horsey, who was a cartoonist for a long time in the PI? It's kind of, regrettably, I don't see his stuff anymore. But if you could go to the next slide. What I'm going to be talking about, yeah, the right arrow there we go, is climate change, keeping with the overall theme of this series, but focusing on the weather of the Pacific Northwest, what the sort of things we're seeing in terms of the kind of shorter term events and how we think that's going to play out. And what I'm going to be doing here, I give you some kind of background material, a little bit about what we've been seeing in terms of the changes over the past few decades. And then it's going to be your turn to help out here. And there's going to be a kind of an audience participation thing where I'm going to put up there a kind of a question that we'll kind of think about. And then folks may know the answer or suspect the answer or have no idea. And we'll just kind of talk about some of these things that may be obvious or may not be, some surprises. So at any point in the proceedings here, please feel free to interrupt, ask a question, or whatever. So anyway, let's go. What I'm not going to do a lot today is talk about, and first of all, how many people have been to other talks in this series? That's what I figured. And so, kind of going through the whole business about global climate change. I don't want to be, there's inevitably going to be some redundancy, but I don't want to do too much of that. This is my kind of doom and gloom slide. Maybe you've actually seen this particular one, but something kind of like it where, of course, what we're worried about is not that the temperature is going to go up a few degrees or something like that, but what it's going to do to the parts of the world that we get benefits from. Food, that's a big deal. Water, all the ecosystems and the benefits they provide. Extreme weather events. That's a little bit, not the only thing we're going to talk about tonight, but something that I think is particularly interesting and not that well known. Go ahead. And, but again, it's just, babies are born every day that haven't heard about climate change anyway. I just want to go through some basics here of, just so we're all at least a little bit on the same page. And so here, the ones that came to mind, is the climate changing? Yes, it is. Not the same place all around the world, not in the same ways, but it is definitely changing. What are greenhouse gases, and we understand their role in climate? We know that quite well, at least what the greenhouse gases are, to the extent that we don't completely understand their role, but we have quite a bit of understanding. This third point here, what's the impact of human activities? And this is something that for some reason, has a lot of legs. You'll see on blogs and that sort of thing, oh, the volcanoes produce a lot more CO2 than we do from the burning of fossil fuels. That is patently false. That is just not true at all. We know that we're causing the increase in CO2 and some secondary constituents in smaller concentrations like methane. The biggie is the bottom one here. Can we predict climate change during this century, and with what confidence? And that's what we're trying to do, get more confidence in our predictions, but this is, we're not all the way there yet. Go ahead. Another cartoon, you'll be subjected to a few of these through this talk, other ones at the end. This is one getting to the point of the distinctions between weather and climate. And this one came out after the harsh winter that I had in the Great Lakes in eastern US this past winter. And the idea that, well, if it was cold, okay, all this climate change stuff is hooey and so forth. One thing that I'm continually puzzled by, what's the Oscar got to do with it? Did they confuse an Academy Award with getting a Nobel Prize? Just what the hell? Anyway, nice touch. So, but anyway, the important thing is things like cold winters can still happen, even though the climate is changing and warming. Go ahead. There for proof that it's happening, I have tons of slides that I've spared you that shows traces of temperatures and everything like that. I think some of the most vivid evidence is just with our eyes. Here is a before and after picture of a glacier in Argentina, 1928 at the top, 2004 at the bottom. And clearly that's a different landscape. If you go to the next one, a little closer to home, here in Alaska, same sort of deal. Has anybody here been to the Portage Glacier outside Anchorage? It's about half, okay. You probably went to the visitor center. It turns out you cannot see the glacier from the visitor center anymore. That visitor center wasn't built that long ago, and that's just a sign of kind of how rapid some of the changes in some parts of the world have been. And so there you can argue about all the, thermometers are different than they were before World War II and all that sort of thing. But this kind of evidence, I don't know. How can you argue it?
I have a question.
Sure.
So there was a point made by Cliff Mass that the climate has been warming since the last ice age, and how were these glaciers receding before the onset of the combustion engine? Were they they obviously were not receding this rapidly, but they were receding.
Yeah, in a lot of cases we don't really know. And and not every glacier, its changes can necessarily be tied to temperature. For example, on Kilimanjaro, it turns out it's more affected by how much precipitation there is versus how the temperatures and so forth. And so and there have been changes before we really started increasing CO2 concentrations. But just saying, in the last few generations, we've seen big changes. Yeah, next slide. Okay, so here I'm going to go through a kind of whirlwind tour, just kind of very selective of some of the things we've been seeing in the changes in the weather in the Pacific Northwest here. And go ahead. If one of the things here, I'm going to get more into event kind of time scale, shorter time scale stuff, but just in terms of longer timescale trends, and this is over the period 1920 to 2012. This obviously shows the Pacific Northwest, and the kind of color of the dots indicate the magnitude and the sign of the temperature trends or change in temperature averaged over this 92-year period, with the redder dots being warmer, a greater warming. Yellows not so much, and there's actually a few blues sprinkled around. And here's something, again, people can cherry pick some of this data. Somebody will go and pick out this place in Idaho, I don't know what the name of it is, and go, well, there's a cooling trend there. You know, this is, obviously it's a hogwash, all this global warming stuff, but what is the preponderance of the evidence here? One of the interesting things I think about this is that the amount of change we're seeing is seasonally dependent. Yo.
I don't understand the background on which those dots are set, and also those acronyms on top. Can you please explain that?
Yeah, sorry. Yeah, this is winter, December through February, spring, March through May, June, August, September through November. The T-max, the top charts, yeah, and forgive me there, these are the maximum temperatures day by day, kept track of. These are the minimum temperatures each day. And again, this is just kind of fitting. We have a time series, let's say at Newport, Oregon here, of their minimum temperatures over this 92-year period, and we fit a line to that trace of temperatures every day during these winter months. And so that when you fit that line, you get a rate of increase there of something like 0.25 degrees C per decade. That's about a half a degree Fahrenheit per decade or so over that particular period. And so the reason I put it up in this form is so you can kind of see the kind of variability from place to place. These smaller dots are where the trends are so small that they're not really, we can't say they're that much different from zero. They're, because there's always noise in this data, there's cold years, warm years, and so forth. A couple of interesting things I take away from this. It hasn't warmed up as much in spring as other seasons. Why? We couldn't really say. One thing, it's kind of subtle, but that it's warmed up more in the minimum temperatures than in the maximum temperatures. And we'll have more about that, especially in the summertime. And we'll see a little bit more about that in a minute. Go.
With all those increases, why are there decreases?
It's just kind of the randomness in the system. Just, it's like an example here. Because of better nutrition, people are taller than they used to be. And just there's no doubt about that. You look at the bunks on old sailing ships and they're about that long or something. But not everybody is taller, and so there's just kind of just those kinds of fluctuations. And that may not be an entirely satisfactory answer, but it's kind of the way it is. For whatever reason let's make fun of Idaho again. I think that's probably in the Snake River Valley, and conceivably it probably gets cold temperatures when there's really settled weather, and kind of like in those kind of clear, calm days in winter and so forth, that in the valleys it can get really cold, and perhaps just it's been more prone to that than the other places around, something like that. I could make up things about it, but it's...
So we're talking about 5 degrees, something like that over that?
At some of these places, yeah. Yeah, so it's been significant. So next slide. But what I'm really interested in are the kind of events here. And with a couple of coworkers actually in Karen Bombaco's in the Washington State Climate Office and Kathy Dello in the Oregon State Climate Office, we did an analysis of northwest heat waves on the west side of the Cascades. And this plot here shows the day of the year that the very top heat waves, these are the upper 1% of the hottest kind of 3-day events. And when they were 180, that's like the end of June, 240 is the end of August. All our really serious heat waves are in July and August. And these are the ones that were the hot day type events that were that lasted at least 3 days, and these are the ones, these are the big ones. And the point I want to make here is that they're sprinkled across the record from the 1900s to the present. There were some back in a century ago, some in the 50s. There was a notable event in 2009, which was the biggest heat wave in terms of magnitude in Western Washington history. And so there's been no real trend in these big events. But look at these hot night events. There were a few in the early part of the record, but almost all of them are in the last few decades. And so what we're starting to see, it's not so much that the days are getting that much hotter, but the nights are. And there's a reason why. And Lee's going to have to stop taking notes. No. Yeah, I'll make fun of him from time. He seems like he's got a pretty thick skin. So. And so what's happening is it's getting more humid here.
The one on that last slide, it did look like there was a trend for these hot days to be happening later in the year.
Yeah, go back one and let's take a look at that. Yeah, and so what you're saying is, yeah, that a lot of them were kind of in July, early July, and then there was a group in August there, and that one's right, kind of the end of July. So yeah, there may be something to that. I'm not sure what to make of that. That could be kind of an accident, just that deal of the cards. But I think it's no accident that we've had almost all of our hot night ones. And go to the next slide. What is happening here, and we've got good records here. This is this number here is almost like parts per thousand of the water in the atmosphere. The more it is, the muggier it is. And I think, it's varied from year to year. This just goes back to 1950 when we have really good records of this. But there's an unmistakable upward trend. Luckily, we're nothing like Biloxi, Mississippi, or one of those godforsaken places or something. It'd be about double this number. My father grew up in Tennessee, and one of his expressions growing up there as a kid was, it was so hot at night, you just had to wet the bed, just stay cool. So, if this gets any worse, maybe give it a shot, maybe it'll work for you. But our record humidity was last summer, and I don't know so much around here, but down in the Seattle area, there were a lot of nights that didn't get below the 60s. And that's really rare. It usually used to get in the upper 50s. And so this is, I think, the cause of why our minimum temperatures, especially in the summer, are going up. And again, we're not quite to the Mississippi's point, and that's a good thing as far as I'm concerned.
How many locations did you use for that?
Yeah, this actually is based on a kind of an analysis. It's kind of for Western Washington. It was either the state as a whole or Western Washington. I don't really recall. And so it was kind of and this has to do with kind of the water content about 200 meters up in the atmosphere. So
not just metropolitan areas.
Not just metropolitan areas. And because, and you bring up a good point there, because the urbanization and stuff like that, some of our measurements, it's really tricky to interpret those. And so I think this is a little bit more robust. All right, let's keep going. All right, precip, that's a big thing. Oh man, I love when it rains. I just can't get enough of that. I've lived in Seattle since 1980, and anyway, yeah. So if you look at, for the state as a whole, and here in terms of water year, I don't know why I plotted it that way, I don't know. You can see there are a lot of variability from year to year, and even kind of drier periods and wetter periods. Overall, there's a kind of slight upward trend, but I don't think that's really significant. And here again is a case where you could imagine how cherry picking could be done. If you wanted whatever answer you wanted, you could find a period that would satisfy that answer. You want to say that precipitation is going down, start your time series in the late 90s when we were really pretty wet. If you want to say it's going up, start in the late 80s when it was dry, and so forth. So go to the next one. What I wanted to do here, and bear with me as I try to explain this dumb graph here, is kind of look again at the extreme events. So what I did for 5 stations in Western Washington, you'll see a slide for 5 in Eastern Washington, is I looked at in the wintertime, October through April, and summertime separately. I looked since 1950 when we have really good data and I kind of trust it. I looked at the 10 biggest one-day precipitation events, and a bubble was plotted the time that occurred. This is wintertime. The size of the bubble is commensurate with how big that event was. So these are the top 10. And so I want to look at a bunch of stations, because if you just look at Mount Rainier, you go, wow, almost all of them are in the last half of the record. There's a lot more extreme events. You don't get the same impression maybe from some of the other places. But overall, my interpretation from that, I'd be very interested if you guys have anything different, is that there does seem to be a few more here than in the first half, right? You buy that? Okay, what about Eastern Washington? There, I don't get that impression at all. It seems like the big events have been kind of distributed more or less randomly over, somebody throwing darts who was really drunk or something, just all over the board. Let's go to summertime. We care about that. Here in the West, I don't get anything too much. Rainier has been rainy recently, but other places not so much. Eastern Washington, one more. Here now it looks like maybe it is maybe a slight tendency. And to do this right, you have to there are more stations and have to do this, but this is what I could do in my spare time sort of thing, that there does seem to be some increase in these big summer events. And it actually makes sense. There's different weather patterns that make it wet in Eastern Washington than Western Washington. And so, that it maybe getting a different answer isn't such a surprise. All right, go. Here's something, a kind of local yokel thing that I just did a little bit while ago. It turns out on Olga, on Orcas Island, the south part, there's somebody who's maintained what's called a co-op weather station. Did volunteer weather observations in the same family, in the exact same place back into the 1800s. I think it's only 3 generations, and I forget the name of the family. And that
Willis.
Yeah.
John Willis.
Yeah, and so they have this great record. Let's face it, urbanization is not a problem with the observations in Olga. That has not been, and so they've been very careful of that, very diligent. And so the idea here is, well, what's their record show? And in particular from a kind of grower, Ron and, the people's point of view, the frost-free, the growing season, that's a big deal. There, the long-term trends, this is the last day of frost. 100 means about April 10 or so, maybe April 15 or so. And so over the record, I don't really see any change in the, and then this top trace is the number of days between the last frost and the first frost the following fall. And maybe there's a tiny increase in the growing season, but boy, it's just more year-to-year variations. And just we've had, not so much in 2013 and 2014, but we had a couple of, kind of lower or shorter growing seasons. All right, next one. Here's something from a farm point of view. Bear with me on this one too. There's some data I've been looking at in eastern Washington. This is in the Columbia Basin where irrigation is done. Something called potential evapotranspiration. Well, that's a lot of syllables. What it actually means is how much water is coming out from a plot of ground that's got sufficient water in it from both the plants and the soil. So how much evaporation from the soil and that's transpiring out the leaves. It's based on, if not the actual measurements of the water itself, but how much energy that there is available to do that, convert that liquid water in the plant and the soil to the vapor, and how fast it's kind of transported away. The screaming message, we only have the records back to the late 80s, but look at this increase here in this. This relates to how much water you would need to keep a field in good shape. And yeah, go ahead.
Wind is part of that?
Wind is part of it. The windier it is, so the ET goes up, the hotter, drier, sunnier, and windier, the more it goes up. Those are the days that dries out a field. So when it's calm and cloudy and humid, then you don't have that. And these numbers might not be so meaningful, but it means like in these places in eastern Washington to maintain that, and so based on a crop alfalfa for what it's worth, it used to be something like 0.28 inches of water per day was needed, and now it's something like 0.32. Big whoop. It turns out over the 100 days of summer or something, that's 4 extra inches of water you need. Whoa, now you're suddenly talking your irrigation system has to deliver more. So if you go to the next slide, and from a point of view from the days that are especially low and especially high in this PET, the late 80s, early 90s, there were a lot of these especially low ET days, and recently there's been more of these high ET days. And a guy I was talking to actually it was Chad Kruger who spoke here before, was saying that some of these circle pivot things, they have to run 24 hours to keep up with the water needs in certain fields. And if the ET needs, if there's a lot of evaporation, a lot of transpiration, they can't just keep up with that. So this is, who knows if this trend's going to continue, but I find it kind of interesting. Okay, there's, I think one or two, go ahead. Winds. That's,
They must be getting a lot of more crop production if they can keep up with the water.
if you can keep up, sunnier is good. That's the energy to, photosynthesis and all that. And, presumably some crops can maybe benefit from that, others don't. This is something an intern that's working for the Climate Office just made a couple of days ago. We have it working for us for this summer, which is why, partly why the plot is kind of crude and all that. But what I was interested in was, is it getting windier around here, the kind of the storms? I don't care about the mean winds so much, but the big storms. And so I had her plot up each year, the times it was in the top 1% of those winds. Here, the top one is Bellingham, and this is Whidbey Island, the naval station at the north end near Oak Harbor. And I've just started looking at this. I'm not sure I've digested it, but obviously there was a data gap there at Bellingham. I don't get the impression that it's getting more storms or less storms. What do we think as a group? There's a lot of dots here in the last 5-10 years. But anyway, we're just starting on this, but so far we don't see the evidence for the storms. Okay. Predicting the future. We'll go through these pretty fast here. Go. The reason we're concerned is that we're pumping a lot of carbon dioxide into the atmosphere. This little map here shows it's a sort of world map with the different countries sized by their And this is in 2009, I think it is, or 2010. The size of the dot is proportional to their carbon emissions. We're no longer number one. China beats us out. I don't know how we feel about that. But if you go to the next slide, we do a lot better in terms of tons, or worse, depending on your point of view, tons of carbon emitted per capita. We're not even number one there. Australia emits more than us. Anybody know why? Coal, a lot, yeah, and probably it's a hot place. A lot of transportation kind of carbon costs there for big driving and so forth. But most of their energy comes from coal, and that's a particularly big producer of CO2 for every BTU of energy. And so we're number two there. One thing kind of interesting, this blue one is for 1990 to 2011. It's actually gone down per capita. Why do you think that is?
More efficient cars,
That's part of it.
Gas prices.
natural gas.
Yeah. What I've heard is part of this has to do with the Great Recession. That just the whole productivity of the country, factories not as humming the same way. I think a lot of it is efficiency also, though. Okay, go ahead. Yeah, the idea that we're doing something in the atmosphere. This is from bubbles in glaciers. We've been able to see what the CO2 concentrations are back in the atmosphere. The time units here, going back in time, are in thousands of years. So this is 400,000 years ago. And you can see with the ice ages, CO2 goes up and down. Hit the arrow. And now this slide's a little out of date. We're actually up to 400 now. And so we're having just a meteoric rise compared to the glacial past. And here's another argument. People say, oh, the climate varied and the CO2 concentrations varied in the past. Well, yeah, but it took thousands of years to change, and we're changing it in decades. All right. And that's causing a warming world. And you've probably seen plots like this. It kind of depends on, this is for the 2020s, this is for the 2090s, it kind of these different sets of plots with the kind of purple colors being more warming reflect different sort of CO2 emissions. I don't want to belabor this one because I want to get to the real goodies, so go to the next slide. We've seen that one before. Keep going. And this is now it's going to be your turn. And I'm going to insist on participation. I'm taking names. So when I've done this in the past, I've actually had people organize in small groups and kind of fill out like multiple choice sort of kind of questionnaires. And I threaten that they have to put their name on it and it's going to go on their permanent record and so forth. But we won't do that this time. But anyway, go next one. What we're going to talk about is some of the hazards that we face around here and whether we think, things like windstorms, big rain events, heat waves. I mentioned that heat wave in 2009. There were 95 hospitalizations in King County alone directly related to heat, 5 deaths. And so while they're not as severe as heat waves elsewhere, they do have impacts. And so there's something to keep track of. So we'll talk about that. Next one. But just as kind of a warm-up, I'm going to lob one in there for you. All right, fat pitch. Who's going to hit it out of the park? Which side of the Cascade Mountains do you think is going to warm up faster? I got a west, I got a east.
We're temperate more by the water, right?
Oh, you guys are pretty sharp. I got to watch out for you. Go to the next one. Yeah, it looks like it's the east side, at least what our models are showing. This is out a kind of an ensemble mean or an average of a bunch of models for this is the wintertime, December through February. And the scale is showing in degrees Fahrenheit in the next, few decades. Yeah, a few degrees of warming. Maybe it's hard to get kind of too excited about that. But it does, like the young lady back there mentioned, we're on the west side here, we're kind of moderated by the ocean, and it has a lot of thermal inertia. And so it's going to keep us from, it looks like it's going to keep us from warming as fast as eastern Washington. Yeah?
It's curious, though, that, you know, you're getting warmer on the east side, yes, but look also at Vancouver Island, which is surrounded by water, and still they seem to be going up quite a bit too.
Yeah, you know what I think is happening there is that's right in a kind of a marginal snow zone. And that's right now, that gets quite a bit of snow in winter. You know, it's not that high elevation, but what the models are showing, that's going to be more rain. And so it's kind of real sensitive to that, because once you get some snow cover, then it's a lot colder. But that's a very good, insightful point. So, okay, so we're not too alarmed by that. Next slide. Whoa. This is 2090s. This is Dante's version of the Pacific Northwest. If this is actually, this is a projection from models, but we're out there, way out there in 6, 7, in places maybe 8 degrees Fahrenheit warmer. This is going to be a different place. And that's something to worry about. All right.
Whose projections are that? Whose projection is that?
This is a bunch of models from different modeling centers all kind of averaged together, smooshed together. And I'll have some slides that kind of show that different models have different, kind of ideas about what's going to happen. So go to the next one.
Is this extreme events that are pushing this, or is it just that nighttime temperature is going up? Is it where's the big difference?
Yeah, it's probably mostly in the nighttime temperatures. Here and you leave this one on, that's good. That's a good question. From what I've seen, not necessarily any real change in the extreme events, especially in winter. Certainly fewer of the really brutal cold air outbreaks. But it's mostly kind of the baseline going up. Here there was a question about, well, which models were saying this. Here's kind of a range. This is just out to the 2040s. Again, the seasons, like I like to separate it out to. Different models have different ideas about how much it's going to warm up. And here I apologize. The units here, sometimes it's degrees C, sometimes degrees F. Just deal with it. I just cannibalized all these slides, so, whatever. But anyway, so 2 degrees C is about almost 4 degrees Fahrenheit. So depending what units they are, does make a difference. The message I want to get across here is that some models are much less enthusiastic about the amount of warming than the other ones. And so this gives you this kind of box and whiskers sort of thing, gives you sort of kind of typical in the range sort of thing.
Is there an underlying cause for that? What's the difference in the model?
They have different assumptions that go into them, kind of things like how they treat clouds, different ways that they kind of solve the equations. They're very similar in nature, but they do have some differences, and basically those differences do play out with quite a bit different forecasts. There's not as much range for when the globe as a whole, but here I'm just looking at the Pacific Northwest. And so one model, for whatever reason, just makes it cloudier here in summer. And so it's going to have, not nearly as much. All right, go to the next one. All right. Now we're getting, this is hopefully kind of tricky. Air pollution. Again, you're talking health effects. I think that's a pretty big deal. If you have sort of chronic problems, respiratory problems, it's a really big deal, like asthma and so forth. So first of all, what kind of air, what's the problem in winter? What kind of air pollution do we get?
Wood stove.
Bingo. Man, you guys are quick. Sometimes it's like pulling nails to get, or teeth or whatever, to get, but yeah, it's wood smoke. It's small particulates in winter. That's our big problem around here. Okay, and so before we get to kind of speculating about which answer, what's our pollution problem in summer, for the most part? Well, that's one.
Burning trash.
But what's the stuff we don't want to breathe in? And think kind of LA. Smog. What's the thing in smog, the compound in particular?
Nitrous.
Ozone. Bingo. Yeah. And so for the most part, in summer, you're exactly right about the wildfires, and we'll talk a little bit about that. But for the most part, it's wood smoke, the small particulates in winter, and so which one's going to be the problem? What kind of changes should we expect? What about our winter wood smoke? Going to get worse?
Yeah.
Everything's going to get worse, right?
No, I think it would decrease with slightly warmer temperatures in the west side.
Bingo. Get that man a cigar. Because, yeah, people burn their wood stoves. It's residential burning of wood, in especially the old wood stoves or, the kind of fireplaces. And when it's not as cold, you don't burn as much. And if you go to the next slide here, here's some traces for this last winter from October 2013 into February 2014. Two different places here in red at Lake Forest Park up near the north end of Lake Washington, in a residential neighborhood, and here in purple or blue or whatever, it's kind of downtown Seattle. And here, this is getting back to the point. No, there's no wood smoke being burned in downtown Seattle, and a lot of cars, but that pollution is actually worse in Lake Forest Park because that's part of the, I guess, just the zeitgeist or whatever. I mean, you burn wood in your fireplace and you drink a glass of wine, whatever, Yeah, but it's, the other point is that we had a very calm, sort of uneventful winter in the middle. We had a cold snap here in early December in which there was elevated pollution levels. There were some periods here in October, very dry, a lot of fog, when it just got kind of, and also in January, remarkably dry, 13-day period without any rain. And so that's when the pollution got worse. And so we are anticipating, good news, that wood smoke pollution in winter is going to go down. Hey, yay for us. What about ozone in summer? Yeah, if you go to the next slide. It turns out right now we get about 5 days on average that hit 90 degrees or so at SeaTac. We're not expecting a meteoric rise in that number until later in the century when it's a lot. And you might think, well, man, the tomatoes are just going to, I'm not going to be around growing them, I'm afraid. But, this is a good thing, be at the beach and all that. Next slide. It turns out there's a very tight relationship between ozone levels and temperatures in this part of the world. Here, this blue trace is the maximum temperatures at SeaTac during the very warm summer of 2009. This is the all-time record heat wave. So it's going up and down. And here in the foothills outside of SeaTac, or Seattle, at Enumclaw is the maximum ozone amounts. And you can see how it tracks with the temperature. And it gets into, when it gets above 50 or 60, that's when it starts dissolving the little kind of material tissues in your lungs. That's not good. And you can see that very strong correspondence with the temperatures. Here, this kind of strange downward kind of thing on the very hottest day. The winds were from the east there. Instead of blowing all the pollution from the populated area into the foothills that day, it actually got some cleaner air. But for the most part, hot days means more ozone.
Where's the ozone coming
Good question. We don't actually produce ozone, we produce the precursors to it. It's kind of a witch's brew of the car exhaust, so kind of hydrocarbons, nitrous oxides and stuff, and sunlight, when it's hot enough, that cooks together to form ozone, and then we blow it up into the winds typically blow it into the foothills. It actually has been shown to damage the trees there. The trees are sensitive to that. Yeah?
Does this have any correlation to the huge increases in asthma?
Certainly the wood smoke, I know, has been correlated with that. In that Lake Forest Park place that I had, they've documented that, especially with the children suffering from asthma, that it's a lot worse when there's kind of stagnant conditions. And so, yeah, I have to admit, I don't know the ozone asthma connection, but the wood smoke asthma is definitely there. All right, let's keep going. All right, so here are just the, if we take care of ourselves and due to the kind of better pollution controls and that sort of thing, well, take care of the atmosphere, we're actually can look forward to lower ozone amounts. If we don't take care of our atmosphere and we have the higher emissions, they've been modeled to go up, and in some places just by a lot. And so you can see there's particularly hot spots there in the southeast. Keep going. But wildfires, yeah, certainly that's a source of wood smoke. Hit it again. And here's a trace, a few spots here from the fires of this summer. In blue is OMAC, and this is kind of units of these this PM 2.5. Red is Leavenworth, the Chewaucum complex fire. The blue one there is the Carlton complex. Values above 50 or 60 in the unhealthful level, pegging the meter there at OMAC for a while. Some of it was even getting all the way to Spokane, and there were some fires actually around there too. So there is some real, it's much more distributed and occasional, but problems with pollution from smoke with wildfires. Hit one more. And we're not completely spared from those on the west side of the Cascades. When the weather patterns are just right and the winds are from the east and it dries out, there have been in the historical past some huge fires in western Washington. And in fact, by most standards, especially how many died, the worst fire in Washington history was there just outside Vancouver. Long time ago, but that could happen today. What I wanted to do, and I put in a proposal that failed, and so I got that going for me, is kind of look into the kind of weather patterns that are responsible for these kinds of fires, and to see how the models were, whether they were going to be more or fewer of those. And so the proposal wasn't funded, so I don't know. But anyway, it could be something to worry about. Keep going. All right, another question for you guys. Ha, great. Well, yeah, good question. Let's say Western Washington. Yeah, that's right. But, how shall we settle this? Like men outside and duke it out in the parking lot or something, right? Coastal or river? Why do you say, why coastal?
What's the ocean level rise?
Glacial melt.
Okay, and then why river?
Increased rain.
Okay, well, that's...
Much higher snowpack level.
Okay, well, let's see. Next, certainly, everybody who said coastal is right. Sea level is going up. This is the scene, December 17th, 2012. That's Alki in the Seattle. Not a lot of people playing volleyball that day. It turned out $1 million of damage was done to homes just along Alki Drive. This was the highest sea level in Seattle history. The tide gauge has been there since before 1900. Obviously, there was a storm on top that was Oh, hey, no hard feelings. No. There were, it was a stormy day that was contributing to it. It was an especially high tide, but this was way up there, and we're going to be seeing more of this. If we go to the next slide here. Say again? What was the date? It was December 17, 2012. And one thing that it wasn't, it was a record, and the highest tides before have been when we've had El Nino, which tends to rise because the warmer water, it tends to go up some. And we didn't have an El Nino, and so if it was kind of remarkable, actually, especially remarkable that it happened on that time. Here shows a couple of places, Olympia and Seattle. If the places here, the kind of red colors are where it's going to be flooded if the sea level goes up 4 feet, which is on the upper end, but quite possible by the end of the century. And so much of downtown Olympia and their Harbor Island, where all the Port of Seattle. If you go to the next one here. Here, another kind of little close-up, a little better slide for Olympia. This shows if there's a background 3-inch rise in sea level, and you get the 100-year storm that everything gets together, the winds push up the water and the pressure is low so that the water kind of comes up, then you get some minor flooding around the city. But if you have the background here of a 50-inch rise in sea level, again, that's on the upper edge of the estimates, at least in the next century or so, and that 100-year storm on top of it, man, this looks like what New Jersey coast looked like after Sandy or so. And so this I think is sobering stuff. So everybody who said coastal, you're right. All right, next slide. But then everybody who said the rivers, you're right also. We're expecting wetter winters and, for what it's worth, somewhat drier summers. I think the gentleman over there mentioned a higher snow level, and so the precip that falls in winter will be more in the form of rain than snow. And if you could hit the next one. Moreover, this looks like kind of some sort of the test your psychologist would give you or something like that. But yeah, one of these dots mean. But this is again from different models showing how much bigger the most intense rainstorms are going to be. Some of them think the ones 20 years out are just going to be about the same or a little weaker than the present ones. Most of the models are showing that the storms are going to be bigger than they are now. And this is the kind of the 20-year storm, the one that's you have kind of a 5% chance of having in any one year, the 50-year storm a 2% chance. And so it looks like our big events were going to be bigger events. And so if you go to the next one, what that means is bigger floods. And what I'm showing here is for the 2020s and 2040s, with how red and how big the dot is how much bigger the floods are on these particular rivers compared to the floods in the historical record. And this is for the 20-year flood, the one that, the biggest one every 20 years on average. And the screaming message is not for every river, but almost all of them are going to be, the size of the floods are going to be 30%, maybe even 50% bigger than they are now.
Why is it thought there's going to be more precipitation?
Basically, the warmer atmosphere, you saw that kind of humidity going up some, is just can supply more when conditions are right. And it's not necessarily more storms, but when everything comes together, it's just going to be a warmer, moisture atmosphere that it can dump more rain. That's the simple answer. All right. And of course, one of the tragic consequences is landslides. This is not the Oso landslide, but another one that was in near Elma in western Washington. And what I use this one to point out is where you really have the problems is where you do other stuff to mess things up. And you can see what has happened there in the recent past, what has been done to landscape, and certainly exacerbated and perhaps even was the cause of that slide ultimately, and that's the clear cutting. All right. Will regional windstorms become more or less of a problem? Everybody and their dog thinks it's going to be more, right? Wow. Oh, you know, whatever. Yeah, 30 years, 50 years, you pick it. More. Okay, well, let's see. It turns out that it looks like there's going to be kind of a shift in the atmospheric circulation pattern, that the storms are actually, it's kind of hard to interpret from this, and just you know, maybe just kind of bear with me here, but just that there's going to be a shift northward, so that where now the lowest pressure is over the Aleutians and this kind of the storm track into British Columbia, sometimes into us, that's going to be shifting a little bit to the north. Keep going.
Does that explain our recent couple of years that have been so mild and wind-free?
Probably not, but it's kind of hard to say. Now, looking at different models, and here's just one thing that I picked out the waves in the models, which is the bigger the winds, the bigger the waves, and that sort of thing. And just an example that this one into the northwest coast has kind of well, a little bit of an increase of waves into at least Vancouver Island and down to the Columbia or so. Less into California, but that other model at the top has a decrease. The screaming message is, we don't know. And there, I'm not sure how cheerful I should be about it, but I can say there's evidence both ways. And one more slide here. I have been involved with some work out in the Bering Sea and looking at the models. There seems to be some indication there, this isn't here, but just an example, this sort of thing. Maybe a little bit of increase here for the autumn. This is year by year, just how many storms there are. Does it seem like it's going up a little bit? Maybe. What's that? Yeah, that's right. But if you look at, go to the next slide, if you go to winter, maybe it's going down, and so who knows, you know what, and this is we want to find out, but there are some things that we may not be able to. And so one thing I am kind of anticipating is perhaps more storms that have their kind of origins as typhoons in the West Pacific. Remember the storm last week that actually got us some rain and stuff, some welcome rain? That actually had its origins as a tropical cyclone typhoon in the Western Pacific. It hit Japan and ended up, our various strongest storms in October and September tend to have that kind of history. The Columbus Day storm is the granddaddy of them all. And there's some thoughts that we're going to have more typhoons in the future. And so there's a chance that not necessarily more storms, but the very strongest ones will be that much stronger in the future. All right, I think I have one more set of questions. Yeah, thunderstorms. This is something near and dear to my heart. It turns out Washington State of the lower 48 has fewer thunderstorms per square mile than any other state. Oh, it's like a dagger to my heart. You know, what's more exciting than a thunderstorm? And then we get the fewest of them. We thinking about any changes here? Increase. How many people have lived here at least a few decades? Like, when I moved here in 1980, and in the climatologies and that sort of thing, the time of most frequent thunderstorms was the spring. April was the hottest month for thunderstorms, and there were fewer in the summer. My perception, and there's some kind of marginal data, is that we're getting fewer in spring but more in summer. And I invite somebody to say, oh, I'm not buying that. Does this seem to you guys like there's been more in the summer than there used to be? Good.
Summer was amazing.
Well, last summer, in that storm in early September, man, there was about 1,000 lightning strikes or something across the state. But I'm saying, the last 5-10 years, there's some marginal evidence to that. And this is something that I think is really interesting. Go to the next. Yeah, this is a picture from that September storm. Hit it again. There's good reason to think like there should be more here in the summer. It turns out, okay, you may have seen one of the other speakers maybe showed something like this where there's, how the kind of energy budget works. With more stuff, that's kind of a technical term, I apologize, right? In the atmosphere, that's radiating energy down to the Earth, this infrared radiation, making us warmer. And, if we didn't have any of this, it wouldn't be a place we'd want to live. We had too much. And, obviously thinking problems. But at the same time, it's warming the Earth. It is radiating more to space. And so while it's warming up here, it's cooling off aloft, and that is a destabilizing effect. And so the extra, and we're seeing that up in the very highest part of the troposphere and the stratosphere, it's getting a little cooler there. And so there's reasons to think, but it, for the most part, can only speculate so far. Go to the next slide.
And why is it getting cooler?
There, go back. Actually, go back here. Here, there's more, along with more radiation of energy toward the ground. There's more to space now with more, junk there, greenhouse gases. Another way to look at that is.
I thought we were talking about thunderstorms.
Right. And so that's making it colder up high in the atmosphere while it's making it warmer here.
And so,
Yeah, but the question was, why is it cold? Why is it making it colder? And I guess that arrow going up is bigger, so it's losing more energy to space. And the reason is when it's cold here and warm below, then that air, the colder the air, the more dense it is. If you have kind of less dense air underneath more dense air, it wants to equilibrate. And so right now it's kind of like you got the vinegar underneath the oil in your salad dressing bottle or something like that. And if we make it more dense aloft and less dense below, then there's those big vertical circulations that cause the thunderstorms. All right. So I want to keep going, and here I'll just drive here. I'll get past here. I want to get to a couple of last points. It's a hot day here, and you guys have been really good about being so patient and answering my questions. But so a couple more points I'd like to make here, and this is one. It's not really kind of a weather event, but it's such a big one that I feel compelled to bring it up. Okay, so what is this? This is your final question, extra credit on your test.
fire, ocean acidification, water.
Water is getting there, but what aspect that's key to our water supply? Bingo. Yeah. That's our water in the bank that we rely on in the summer. Here, you guys, obviously, all right, there's not a lot of snow melt here to rely upon. But for most of Western Washington, we don't have the reservoir capacity. We rely on that snow melt to get us through the dry period. And if you go to the next slide here, our forecast area, this is the present amount of water, this upper trace here, that is in the snowpack, if it was all melted out in kind of millimeters for what it's worth. This is kind of our present climate, what we're expecting in the 2020s, 2050s, and by the end of the century, there's just not going to be much snowpack there. And that's a drag. That snow, everything from hydropower, agricultural needs, ecosystem health in the freshwater streams and so forth. Boy, that's the forest health. That's bad news. All right. So just a few more here. Just to sum up, will it get stormier in the fall and winter? I don't know, and I wish I did. Will the summertime humidity continue to increase? Probably. And man, that's a drag. But will there be any changes in these thunderstorms? And will we kind of continue to see maybe it's kind of a different sort of thing that makes it thunderstormy in the spring, kind of decrease then in more summer ones? Yeah, maybe. And here the big one, there's going to be some surprises. What kind of things are going to catch us with our pants down? It could be things as suddenly a mosquito, Asian tiger mosquito, suddenly can inhabit eastern Washington, and some of the diseases that go with that. It could be, a fungus that devastates the wheat crop in the Palouse or something. There's the real potential for this sort of thing.
There's already a major impact on sea stars, which I think has been linked to...
Right. Right. Yeah, and so we have to be prepared for kind of nasty surprises. So next, and so even if I would not be surprised at all if one of the previous speakers had this slide. If not, shame on them, right? But some of the things we can do are good things to do anyway, right? And so I'd argue that there's a time to take some action. Finally, I think my very last one is, just so you can page through these. Okay, climate is changing, yeah, right, keep going. And like I said, surprises, one more. And we're studying this. That's part of the work that I'm doing, hopefully I'll be able to come back in a few years and be able to tell you more about this, but one more. But I do want to close with this one. Because again, it's like the pictures of the glaciers. I think this is the evidence, this is the strongest evidence we could possibly have. And so with that, I'll close. Thanks. Yeah, and
first an observation, and then maybe you could comment. Around here, we're in the 20-inch a year range.
Yeah.
And a lot of our rain comes in events, a few events, Pineapple Express events,
right,
which is a significant percentage of our rainfall.
Right.
So if that fire hose changes and agreed to, it could have a big event.
That's right.
Is there any evidence of it changing?
There's probably what's going to happen is that there'll be somewhat fewer events, but more intense ones when they happen. And I don't want to bother paging through the slides there, but overall we think that it's, for the region as a whole, wetter winters. Drier summers, even more of a Mediterranean climate than we have now, which is actually the proper characterization. And so those Pineapple Expresses will be even, man, it won't just be a tiny little whiff of it. It'll be like a Mai Tai was thrown in your face or something like that when you get it. I'm not sure how that metaphor works, but anyway, bear with me.
So just to get practical, so based on what we think we know, what people know, is there any things, are there any things that people should do? Anything in the way of preparation?
Well, yeah, people are starting to do this. In the city of Seattle, I know the public utilities is taking this sort of information into account and designing kind of storm water systems and so forth. And so to kind of, at least for the example of the heavier precip amounts, and also for the water supply, trying to at least have a cushion there with the expectation that drier summers, maybe longer summers, that we're going to have maybe more capacity to kind of get through those times because we won't have the snow melt. So yeah, people are doing stuff with it.
From an energy perspective, doesn't that mean that we're going to have to do something about summertime supply of electricity since we're so heavily embedded in hydro?
Yeah, that's right. And right now, almost all our, well, a lot of our hydropower comes from the Columbia River system. And there, it's actually managed so that, well, there's half the water in the Columbia comes out of Canada. And there's, it's kind of managed between the US and Canada, partly for flood control, partly for power supplies, and there's kind of big money involved there. And so, yeah, that's being talked about. I'm not sure if there's any real solutions there, because the problem is if there's more rain in the wintertime, Canada is going to have to get rid of that water out of the reservoirs that they now can kind of hold, because it's coming down as snow rather than rain. And so they can, they're not going to provide the same kind of flood control that they do now for us. And moreover, there won't be then that water for the summer hydropower. So that's a real concern. Yeah, the gentleman in the red, yeah, go ahead. And
Do you have any sense of what the climate change would have an effect on an area that's already in a rain shadow, as we are?
yeah, that's something that's still kind of an open question. And in that we can kind of say something about the kind of broad patterns of change, but what you're talking about there, and what you kind of asked about too, you know, these Pineapple Expresses, that is a very particular angle of attack sort of thing that is so key. And if the winds are from the west, then Port Townsend isn't as dry as if they're from the southwest and that sort of thing. And so the short answer, we don't really know to that detail yet, or can say anything with confidence. But for the most part, we expect the dry places still to be on the dry side and wet places to be wet, and so forth. Yeah.
So, going from that question, then a question about the jet stream. And so with polar amplification of temperatures and sea ice disappearing, a couple decades, it could be all gone by late summer and fall. That's going to have a profound effect on the jet stream because of the temperature gradient difference between the subtropics and mid-latitudes and the north. And I've heard a lot through some of these talks, have been great, but I'd just like to hear a little more speculation. I realize the data, it's fairly recent, it's very complicated about all this business, but can you just speculate a little bit if, in a worst case scenario, 20, 30, 40 years, what we might be looking at here with extreme events with, basically with blocking?
Yeah. The jury, isn't, it hasn't even been called there, I would say. It's not even in deliberations yet, in that we really haven't figured that out. And there's been some tentative evidence that the changes in the Arctic indeed have these impacts on the jet stream, and with consequences, the weather elsewhere. But I haven't seen really solid evidence that we can count on that, the sea ice being a major role there. And I'm actually involved a little bit of some research of that sort. And that is, if you remember a couple of slides ago, that is kind of one of those kinds of surprises that may happen, that there'll be changes in the circulation that we just didn't really anticipate. And but I wish I could give something more definitive there, but it's among the scientists, the real scientists, it's quite controversial and is by far from settled. Yeah.
You had talked about storm systems moving north over a period of time. What's causing that?
That is kind of what this guy talking about, that the sort of the warming of the poles and that, and the kind of the temperature gradient that, or differences that drive those storms, kind of shifting poleward. And so the kind of the storm track, and that's a pretty robust result, that it's going to be moving a little bit from the present latitudes a little further north. So I think maybe a question or two more. I appreciate you. I could stay here all night, but I'm not sure if you guys, yeah, go ahead.
What do you know about the effects of geoengineering on weather
Ooh.
patterns?
Yeah, I was kind of wondering if I was going to get one of those. Yeah, and that's a big one. And that's one that is very complicated from a kind of regulatory point of view. That if we do geoengineering, and who knows, we may want to, it may be, and there are negative effects of that due to kind of changes in weather patterns, then, you know, somebody's got to pay. And that's, I think, a good argument for against doing much of any of that sort of thing. But
Do you not think it's happening now?
well, we are doing a grand experiment with the global weather, but in terms of intentional things like seeding clouds and putting up stuff in the stratosphere to reflect sunlight, other ways and that sort of thing, boy, when you start doing, playing those sorts of games, there's kind of a lot of liability issues that come up there, and boy, that's a can of worms. Man, do we want to open that one? Okay.
What are your thoughts about melting permafrost and the escaping methane causing 20 to 25 times as much damage as
Yeah, it's the methane concentrations haven't gone up quite as fast as feared. And, but that's definitely a concern. One good thing, methane has a shorter lifetime in the atmosphere than CO2. It's something like a few years, while CO2 is like 100, 200 or something. But still, it's a much more effective greenhouse gas. And that is something that we're trying to figure out why is not more of it coming up than seems to be. It is increasing, but not as fast as feared. There is the potential that it could really exaggerate the problem, though. Well, I'm going to leave it up to, again, I'm happy to stay here. If you guys want to kind of filter out, that's fine, and I'm going to stay around some, but anyway, let's call it.
Okay.
Hey.
That was a great talk and entertaining and informative as well. So this was the 5th talk in our series. Our 6th talk will be next week. It will be Rebecca Lofgren from the National Parks, and she will be talking about glaciers. She's a glacier monitor, so she'll have